All right, so first thing I'd like to get out of the way is an announcement. So Axtria is having a tech talk on October 6th at 5:30 p.m. Eastern Time. They're going to be talking about what projects analysts and associates work on at their company. Furthermore, Axtria is hiring, so this is a good chance to show up, for them to see your name and for you to get a chance to apply for their jobs, their internships, and figure out what they have to offer. So this is the QR code you can scan to register. So I'm going to give you guys a moment if any of you want to scan this and register for the talk. Again, so that's 5:30 p.m. Eastern Time. Even if you don't know right now if you're going to be available or not, I recommend registering just in case. This is a good opportunity. So yeah, I'll give you guys like 30 seconds, a minute to scan it. All right, so if anybody later on maybe didn't get a chance, we can go back to this, but let's begin. So the overview of today's meeting, so we're going to talk about linear regression, least squares regression, and a function approximation. In our previous two meetings, we first did an intro to Python, and then the last meeting we did more about an overview of data science, and one of the aspects of those were statistical tools and models that we used. And one of those main ones that you're going to learn about and we're going to talk about today is the use of regression. And so first of all, I'd like to ask, does anybody know what linear regression is or have an idea of what it could be?
Yeah, linear regression is just basically when you have a set of data points and you try to find if there's a line of best fit, a straight line of best fit that can provide some sort of prediction of the y value given an input x.
Good. Do any of you have a guess, or can you give me an example of a real world example of where we might use linear regression, like in the real world?
Maybe you have something like you're trying to predict the value of a house and you have square footage and maybe one or two other different quantitative variables, and then you want to predict the price of the house. You could use linear regression for that.
Good. Yeah, so today we're going to cover some of the basics of, usually whenever we learn about this, we will learn about just two variables, like an x and y, two variables that have a distinct relationship or not. But in the real world, there's often a lot more variables. Like Greg, that was a good example of house prices, is that there's a lot of different variables, like the size, how many bathrooms, and so oftentimes we're going to have to actually deal with more input values. And so good, it's good. Okay, so what is linear regression? So it's one of the most basic forms of regression. So it models relationships between two variables, and it relies on an explanatory variable and a dependent variable. So the linear regression comes in the equation of the form y equals a plus bx, or y equals mx plus b. So this is it's a classic, just a linear equation. So x is the explanatory variable and y is the dependent variable. For example, if you're looking at house prices, so the dependent variable would be the house price, and then explanatory variable, which explains the change of y, would maybe be something like how many acres of land, how many rooms, etc. So the slope of the line is b, or the coefficient of x. A is in the intercept. So this is basically something that's very basic math. you've probably all learned. It's just a simple linear equation. And the complexity refers to the number of inputs. So for example, with house, the more variables you have, the more complex it's going to be. So some of the pros of this is that, first of all, it's very simple design and easy to interpret. For example, if you have a graph and you can relay different variables on the X and Y axis, and you can show a clear or a certain correlation or a relationship between those variables, then not just statisticians or data scientists can interpret that, but you can show that to people in other industries, in other fields. It's very easy to just read it and understand what it's trying to show in terms of the relationships of those variables. There's a one scale factor to input variables. If more than one input is needed, you can expand it to planes or hyperplanes. And I'm going to show you a couple of diagrams and pictures of this later. Because whenever we think of X and Y variables, we usually think of it as two-dimensional. We just have X going horizontally, Y going vertically. As you'll see later, is that sometimes we actually extrapolate this to a three-dimensional plane. So making predictions. So this is appealing because of the simplicity of the equation. Predictions rely on plugging in inputs and a height versus weight. So for example, if you have a linear regression or you have a graph that relays the relationship between different variables, what you can do is that the more accurate or the more related those variables are, the more accurate you can predict the Y, the dependent variable, if you insert the input variables. And so this is really good for making predictions. For example, if you have a graph or an equation interpreting house prices, then if you look at a house for sale in a neighborhood, based off the variables about the house, you can estimate what is the actual value of that house price. So for example, if you input all the attributes of that house and the property into your equation and you find out the house should be worth around $200,000, but the people are selling it for $120,000, like, I'll buy this house, I'll sell it, I can make $80,000. I'm getting a good deal on this house. So the second thing we're going to look at today is the least squares regression. Does anybody have any idea of what this is?
Yeah, when you're trying to calculate a line of best fit, you may look at the difference in the predicted values and the actual values, and then you can kind of try to minimize the square of those differences to get your best line.
Good, good. All right, based off that, can anybody predict or give me a guess of maybe why would we use this instead of linear regression?
Because depending on the amount of variance in a set of data, least squares regression might give you a more accurate prediction, and it might also minimize the impact of outliers.
Good. And can anybody answer me of why would we seek more accurate predictions in data science?
Why would you want inaccurate predictions?
Yeah, good. It's a very simple question. Is, that's the whole point of what we're trying to learn and why we are using these skills, is that the more accurate data and results we can basically get, the easier and more efficient we can make and do work. For example, let's say I own a car company and I have somebody that hits a hammer against a piece of metal. Half the time he breaks the car, half the time he fixes the car, right? That's very impractical. I lose a lot of money. So if I can make it so that every time he hits the hammer, there's only a 1% chance he breaks the car, then I'm saving a ton of money. And obviously that's a very drastic example, but in the real world, getting improvements in results or more accuracy by even tenths of percent or even 1%, whenever these companies work at such a large scale, that little tiny percentage of accuracy is going to translate to millions, if not billions of dollars in savings, profits, revenues, etc. So this is really why a lot of companies, they hire data scientists, they hire people to find a more efficient route. This is why they have different alternatives and they compare the results, because at the end of the day, these companies are looking ways to be more efficient, more productive, and if you can make them more productive by a slight percentage on a large scale or in large data quantities, that's going to translate into a lot of money. You know, they're going to pay you $100,000 salary, but you're going to save them a lot more than what they're paying you. So at the end of the day, these skills, we want to learn them so that whenever you guys go in the workforce, that you're truly worth way more than what you could be. Is that we want to make it so that companies want to hire you, and that, you know, they're not questioning whether it's worth paying you a certain amount. We want you to be productive and add value to the companies that you work at, and it's going to make it easier for you guys to kind of work your way up the chain in the companies. That the more worth it you guys are at your respective fields and your respective industries at jobs, at the end of the day, your life in general is going to be better, and the company's going to be really happy to have you. And overall, this is like the main goal, is that we want to be more efficient, more productive. And so anytime new technologies come out, new mathematical computations come out, is that you guys, we want to be on top of that. We want to learn that, and we want to compare it to what we already know. And we want to see, is this going to give me a better result? All right, back to least squares regression. So this is a common method for fitting regression lines. It minimizes the sum of the squares of the vertical deviations. That sentence right there sounds pretty complicated, but it'll make sense once you guys see a illustration. There's no cancellations between positive and negative values. For example, if I'm building a car, I want to look at all errors. For example, if I'm making a piece of metal, if I make the piece of metal too big, that error is just as important if I make the metal too small. At the end of the day, you basically want to take the absolute value of how far you are away from what you're actually trying to produce. So for example, here I have two illustrations. So on the left side, we have a scatter plot with different values, and then we have a line that would be the linear regression line. And on the right, we have the least squares regression. And so this basically shows you the size of the error as you go along from left to right. So let's do a quick example. So here, Sam found how many hours of sunshine versus how many ice creams were sold at the shop from Monday to Friday. So X is the hours of sunshine, Y is the ice cream sold. So then you have a bunch of data points. So let us find the best slope and y-intercept that suits this data. So just looking at this, can any of you predict if there would be a correlation between these two variables?
Yeah, there should be a positive correlation.
So can you just give me a logical explanation? Why would there be a relationship between hours of sunshine and an ice cream sold?
Because the hotter it gets, the more you want something cold, like ice cream.
Good. So for this example, so for each input, you want to calculate x squared and xy. So then you want to sum x, y, x2, or x squared, and xy. So this is going to give us the sum of x, the sum of y, the sum of x squared, and the sum of xy. After that, we're going to calculate the slope m, calculate the intercept b, and then we're going to assemble the equation of a line. So for this example, our line ends up being y equals 1.518x plus 0.305. And so there's the line, the black line, and then the blue, those were our input values. So this line, it kind of looks like a linear regression line, but yes, it is a bit more accurate. So now we're going to move on to multiple linear regression models. So this uses multiple predictor variables. For example, house pricing, coincidentally, which was brought up earlier. So there's a house price null problem, and there's many features. For example, we talked about the size, like acres, the amount of bathrooms, the amount of kitchens, etc. We're going to talk about height. So this is going to deal with different dependent variables. And then we're going to also talk about multivariate regression models. So for example here, I guess we can skip this for now. Some of you may not know the syntax of that. So here we have a quick example of an equation where we have a y equation, but we have different amount of coefficients and we have different x or input variables. So the b here, this would be the regression coefficients. As you can see, there's one assigned to each x or input variable. And also furthermore, you could also have polynomial regression models. For example, different variables may have a different relationship with the dependent variable. Some variables have a linear relationship, and some variables have a quadratic or a non-linear relationship. So for example here, these are two different graphs. For example, first with linear regression, we've thought of it as a two-dimensional plane of just x and y. And here are two examples of what your graph may look like if you basically go into the third dimension and you have multiple variables that all have a relationship with. So this is very useful, especially with, house pricing and other things. These graphs, they look pretty smooth. They look pretty clean. Oftentimes with different variables that maybe don't have a clear relationship or correlation, you're gonna get some really weird curves and graphs. But our modern technology and modern software, we're able to extrapolate this data and present it visually. And so we can more easily understand what is the relationship between these variables, and it really helps us visualize and understand and maybe provide an explanation why these variables react the way they do. And yeah, I mean, linear regression is a very useful tool. Without linear regression, we wouldn't have, honestly, linear regression has been responsible for so many advancements in technology and in science, for example, in studies all the time. If you look at so many statistics and studies, they're really studying the relationship between two variables. For example, somebody's education and comparing that to what type of job they make, how much they end up earning, or maybe even politically, what is the relationship between somebody getting an education and how they vote, or what's the relationship between somebody's wealth and how much property they own. And also, there's a lot of, like the examples I just listed, is that a lot of those variables in the relationship, it's usually logical that for us to interpret that there's probably some relationship. But in the real world is that there's lots of variables that it might be counterintuitive. We might think there's no relationship at all. But by using linear regression and these tools, we're able to figure out if there actually is a relationship or a correlation. The third thing we're going to talk about is function approximation. So what you can do with the variables. Does anybody want to guess what function approximation is?
Like if you had a bunch of X and Y points that, let's say, without you knowing, maybe it was originally a sine curve and a bunch of points on there. Did you, through math, figuring out that that was a sine curve or whatever the function is that they came from?
Good. Anybody else? All right, sweet. So the reason why we use function approximation is when the problem is too big or too out of hand. For example, if there's too much memory or too hard to compute. In our specific case, if you're working for a company or specifically you're working with data, is that lots of times you get too much, there's too much data for you to use some of the previous tools. And furthermore, if you try to use the past tools we talk about on very large amounts of data, then it's going to take very long for it to compute. And sometimes it's literally not worth waiting that long for data to compute. A good example about this is if you look at our current weather radars, we still to this day, we can't really accurately depict weather. So every day, if you look at the weather, you really care about the weather for tomorrow. And oftentimes, they don't tell you exactly what happens in terms of the weather, and they don't really correctly predict it, right? There's always some variance, there's always some error. And the reason for that is because there's so many variables and there's so much data that their models need to take in, is that it would take too long for those computers to actually compute the actual result of the weather. So what they actually end up doing is that so it doesn't take as long, they basically increase their amount of error, but they make it so that their computers can calculate and predict what the weather's going to look like for maybe the next couple hours, the next couple of days, the next couple of weeks. For them to compute the weather accurately, it would take the computer a literal whole week of computations to give you the results of the weather. But for our practical purposes, what would be the point of them telling us the exact weather if it took them a whole week to tell us, right? Because we need to know what's the weather going to look like now. So that's a good example of where there's literally too much data, so we have to use approximations. So function approximation is a viable method. So it generalizes an estimation of the value for states with similar features. So Greg basically, he was very close to the correct answers, that just like linear regression, right? We created a function or a y equation so that we can approximate what the value will realistically be or predict it. And in this case, where we have so much data that we can't use those tools, then we use function approximation. Some of the attributes and uses. So there's linear combinations of features, neural networks, decision trees, random forest, and nearest neighbor. We're going to go more into these later. And in our first project that we're going to do, we're actually going to be utilizing, and you guys are going to get a chance to practice using the different regression techniques and even try a little bit of function approximation. Here are a couple of external references. We have some different university and nice websites for you if you're interested in learning more or reading about regression. So that was pretty much it. So today we covered linear regression, least squares regression, and we quickly covered a little bit overall about function approximations. So in our first project, which will probably be next meeting, you guys are going to have an opportunity to either by yourself or with a couple of partners to get together, and you're going to get a set of problems, a set of data, and then you're going to go more in depth of utilizing regression, and you're going to be able to, at the end of the meeting, basically present your findings, present your conclusions, and also you're going to give an explanation of what the differences are between these regressions and function approximations, and why maybe in one instance or with one group of data you had to use one over the other. So at this time, does anybody have any questions, or it can be about the Axtria talk this Wednesday. It can be about any of the regressions, future projects, anything.
Yeah, so next week, are we presenting a project or are we going to work on it during this session?
So basically, so the next meeting, you guys are gonna get either assigned a certain, like a partner or two partners. If you want to work by yourself, that also works. So you're gonna basically be given the project, and then you guys are gonna work on it, and then it's not going to be a project that's like a week project. This first initial project, this project's really meant to get you guys kind of get to know, for you guys to like talk to each other, get to know each other, and then hands-on work out some problems. And then at the end, you won't present it, but you will submit it. And basically we're going to utilize breakout rooms, but we also want you guys to be able to ask questions. So I will be there. So if you guys have any questions, you can ask me. If you guys have any questions about what's the software, Excel spreadsheets, stuff like that, I'll be here to help out too. So I don't want you to guys think of it as like a homework assignment that's due at the end and then, it's worth points or something like that. But you will be submitting it and we will be going over it, and then, yeah. All right, any other questions?
For the Data Quest subscription, is it says it's a free plan? So does that mean it's limited to 2 courses, or I was confused what we have there with Data Quest?
So Jordan, you want to answer that?
Yeah, I don't believe it should be the free. I could double check that, but so like when we sent the initial email, you probably got it like an email from DataQuest that was like asking you to like redeem your password or reset your password, right?
Yes.
Okay. All right. In that case, let me double check. And this is Parker, right?
Yeah, because I went and set my password. I think I got an email to set my password, and then I checked my account, and it says my plan is free plan as a team member, and it hasn't restricted me yet, which makes it make me. I would think that wouldn't be able to see like step 3 or step 4 of the data science track, but I can see those, and I've like looked at the first few. Maybe it'll stop me once I finish an entire step or something. I don't know. I don't quite understand it yet, but I've been working on it and was wondering.
Okay, gotcha. Yeah, let me because it shouldn't be restricted the way we have it set up, but let me double check that, and then I believe you're in a group me, right?
Yes, I am.
Okay, so if it seems like it's not restrictive, then I will reach out to you individually. If it is restricted, then I'll push something out to just an announcement to let everybody know what's going on.
Okay. So far, it's not restrictive, so I think you're fine. We're fine. But,
Okay. All right. Cool.
I'll text in the group me, I guess, if I get restricted.
Okay. Cool. Yeah, that sounds good. But thank you for letting me know about that. I have not heard of that before.
All right, so I was wondering if you guys could either raise your hand or somehow type something. How many of you are planning to show up to the Axtria Tech Talk? We got 1, 2, 3, 4.
I know you said that's on Wednesday, right?
Yes. So
What time again on Wednesday?
5:30 p.m. Eastern time. So here's the QR code if you want to register. So they're going to basically talk about and present the projects that analysts and associates work at their company. So they're basically going to talk about their company, what they do, what you should expect if you do work there, what skills they require, what skills they develop. They are hiring, so just showing up to this tech talk is a good way to show your face, get them to see your name. At the end of the day, whenever these companies are hiring, they're going to definitely prefer the people that show up and are interested and know a bit about their company. So this is a good opportunity to basically hear about Axtria and then get basically in their face.
You said Wednesday, but that date, October 6th, I believe, is Tuesday. So which one is it?
It should be Wednesday. Let me just confirm that. Now I want to double check as well. Yep, it is. Okay, it is the 6th.
Okay, yeah, so Tuesday. My bad, I misspoke.
No worries. Good catch, though. Thank you for calling that out.
Um,
All right, so yeah, Tuesday at 5:30 p.m. Eastern time. It shouldn't be too long. I mean, it should be like any other tech talk. Probably an hour.
Yeah, they're looking to do an hour. They're going to have one representative who has a background in math and statistics and a minor in management. So she does a lot of development with R, Python, SQL, like statistical modeling and like machine learning. So she'll be coming from that perspective. And they also have a representative with a background in chemical engineering, but she also does a lot of programming in R and Python. And does kind of like business intelligence and data analytics for them. So they are, it's a consulting firm focused out of pharmaceutical and medical fields, or that's who their clients are focused in, rather. So, I'm sure it'll be a lot about consulting and then how they kind of really tailor their delivery to, clients in a specific industry.
So yeah, do you know when the deadline is to register?
No, they didn't say it will close out, so it should be good right up until the event goes. But I know that they're going to be kind of checking, who's registered ahead of time. So if you're serious about really networking with them and maybe getting a job with them, obviously getting your name in front of them as soon as possible is going to be a good call. Especially, if you have LinkedIn and stuff, they're going to start checking you out on any of your professional outlets too.
All right, last opportunity for you guys to ask any questions. It can be about anything. It can be about the weather. It can be about anything. All right. Well, that's going to conclude today's meeting. It was a pretty quick and short thing about regression. So yeah, I hope everybody who shows up to the Actually talk, I hope you guys, wish you guys the best of luck with Axtria. And I also look forward to next meeting and working on the project with you guys.
Yeah,
Thank
thanks
you.
so much for coming out, everybody. Cool, good stuff.